Okay, finals review packet number 7. So here we're taking 5 cards out of a deck of 52. What's the probability that we pull at least one king? So remember in class, one of the key words or one of the key phrases I told you to always be on the lookout for was this at least. Because often when you're looking at least, sometimes it's better to find the complement and then just subtract. So here, if we have a 5 card hand, at least one king, that could mean a hand with 1 king, 2 kings, 3 kings, or 4 kings. If we were going to do it the brute force way, we'd have to figure out the probability of each one of these 4 events, add them together, and then get the probability of 1 king. Actually, what's easier to think about here is the complement principle, and we could take 100% minus the probability of no kings. Because once we know the probability of no, if we the complement of no kings is having at least 1 king. So that's the trick to this problem, is to think about finding the complement here. So the probability of no kings, for probability, when we have equally likely outcomes, we go to this fraction approach. We have the total divided, the good outcomes divided by the total outcomes. In this case, the total outcomes would be all the 5 card hands we could pull out of a deck of 52 cards. Well, there's 52 cards to choose from, and we're choosing 5 from the deck. So that would be the total hands here. And then in terms of no kings, well, if the 52 cards split to 48 that are not kings, and then 4 of them that are kings. So if we're thinking about no kings, we need to take 5 cards from these 48. And so that's what's going to be on the numerator here, is 48 C5. So still 5 cards, but we're drawing them from the group of 48. And now we're in business to get the total, the probability of greater than or equal to 1 king. We're just going to use the complement principle. 1 minus this thing right here, 48 C5 over 52 C5. Punch that into your calculator, and you get approximately 0.3412, or 34.1%. Okay, number 8. So for this one, I'm going to call this first question, question A. The second question will be question B. Okay, so question A is, what's the probability that I get 8 tails followed by 2 heads if I flip a fair coin 10 times? Well, the first thing to make sure we understand here is that these things are going to be independent. And again, what does independent mean? Well, that means that the probability of one event occurring is not influenced by any other event occurring. When probabilities are or when events are independent, we can just multiply their probabilities together to get the probability of everything happening at once. And so that's what's going on here, is we have 10 events, 8 tails followed by 2 heads. And so we're just going to multiply the 50% chance that we get 8 tails by the 50% chance that we get 2 heads. And since we care about this order in particular, we're kind of done with the problem when we do that. This is a very small number. If you put that in your calculator, you'll get 0.000977. And that's the probability of that very specific pattern occurring of 8 tails followed by 2 heads. Okay, so for part B here, it's really the same thing, except we need to think about all the other patterns which could occur here. If I write this as some letters, what happened in A was we had tail, 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 head, head. One way I like to think about these problems is to think about this as a 10-letter word. 10 letters. And we had 8 of the letters are T, 2 of the letters are H. So for a question like B, when we say what's the probability that you get exactly 8 tails in any order, I like to think of that as how many ways are there to rearrange this word, right? We have 8 tails, but for this one we don't care what order they come in. And so the number of ways to arrange 8 tails and 2 heads, it's almost like that. It is that repeated permutation problem. We're going to take 10 factorial, that's the number of ways to arrange these 10 things, and we're going to divide out the repeats. 8 factorial, 2 factorial. So that would be the number of arrangements. The number of arrangements of the ways that 8 tails exactly could occur. And then to finish off this problem, we're going to take that number, 10 factorial over 8 factorial, 2 factorial, which I believe is 45, and then we're going to multiply that by what happened in A, because it's the probability of 8 tails and 2 heads. So here we've kind of taken into account the probabilities. Here we've taken into account the number of ways it can happen. And then when you punch that into your calculator, you get 0.0439 or 4.39%.